Hello students, welcome to the today's sessions. It is on unit 3, data mining. Here we'll see what are the techniques we are going to study in this unit. Okay, in this unit we will be studying why data mining, what is data mining, a multidimensional view of data mining, what kind of data can be mined, and what kinds of patterns can be mined, and what technology are used, and what kind of applications are targeted, and major issues in data mining, and a brief history of your data mining. This is what we are going to study in this part. Okay, before going for the entire session in depth, we'll see what is data and what is information and what is knowledge. Okay, now it takes some numerical value. What is your data? Suppose if I take the value as 25 here, that the meaning is it is a numerical value. It does not have any uh, context for this one. Suppose if I put a dollar symbol in front of this 25, it gives us a information that is some value of that particular number. That is the money value. Okay, now, so what we come to know here is data is nothing but a raw fact which does not have any meaning. If we put a meaning for that data, we are getting information. That's what we put a dollar symbol in front of 25, which is give us an information. Okay, if we consider how the informations can be converted into knowledge, if we put informations with the rule, then I can tell it is a knowledge. Suppose if the person's salary for an hour is $25 means, so it gives some knowledge. So this particular job is having a issue of 1 hour, it is they are giving $25. Like that, we are coming to know some knowledge from the information. So in fact, if you want to speak what is the different criteria for all those things, means data is nothing but a raw facts and figures which does not have any meaning. Okay, then what do you mean by information? Information is nothing but if any context has been given to your data, then it is called as information. Okay, then we'll come for next is knowledge. Then what do you mean by knowledge? Means any information plus rule gives us knowledge. This is the three scenarios where we are considering data, informations and knowledge. If you take another example like suppose Mm, uh, data in the first quarter, second quarter, third quarter of the year. Suppose 1,000, 2,000, 10,000, like 2,000, I'm giving some value. You will not understand what you mean by that, but you know it is some data. In the first quarter, I'm telling it is 1,000. In second quarter, I'm telling it is 2,000. In third quarter, I'm telling it is 10,000. Fourth quarter, I'm telling it is 2,000. So this is the way I'm arranging my data. So you'll come to know what is this quarter, what is this 1,000. So if I give the context or meaning for this data, suppose I'm telling this quarter is nothing but the seasons of a particular country, and this numbers is nothing but the product of the, say suppose if ice cream company is giving the this much uh, product has been sold in this particular quarter. So that's what it has given some informations. So from that, what knowledge we are going to get it means, suppose we can see which quarter it is going to increase. That's mean we can tell it is a third quarter. So suppose if it is the month of March and May, it is summer season where we can have more number of profit. So this is the way how you can predict the data. That is simply if I'm taking a data, it will does not have any meaning. If I put a definition for that data, I will get a information. If I put a rule for that information, I can get a knowledge. So this is the way how the data, information and knowledge has been linked one over the other. Okay. Now we'll see one by one the topic. Okay, we can see why we are going for a data mining. Here, the explosive growth of data from terabytes to petabytes. So, We'll see why the data is so important. Okay, take one scenario of your example. Suppose I am having a system which is can be holding the values of capacity is 1 TB. Okay, so I'm having a 1 TB of data. Suppose in case all my data has been filled, but I want to introduce a 1 GB of data which I don't have a space over there. Then what I will be doing it, I will be having a two situation. That is, either I will be adding one external hardware to that, or I will be removing the existing data. So for 1 GB of a data, we feel that no need for going for external hardware. Later we will remove the unwanted data. So what we will do, we will delete the unwanted data in the recycle bin, or else we will be deleting in the temporary file. So we can add our data. This is our individual person scenario. Okay, if we consider the same situation for the social media, take down, say for example 40,000 TB is the capacity of one social media is having it. So in that scenario also take it at all the data, I mean the entire size of the system has been filled. Suppose if I want to introduce a new data which is taking 20 TB, so what I will be doing, there is no space for me. So for in that situation also two criteria will be there. One is adding a new device, or else removing the existing one. The people will never go for removing the existing one. You can see in your daily life an example. Any of your social media will not send a message to you that due to some storage problem we are deleting your data. So because your data is very important for them, so when they will never give a message, so they will be adding a extra storage space to store the data. If you see the two kind of places, when you are ready to delete your data, but the outside social media is not ready to delete your data, because they are expected your data. That's what your data has been have a important for the outside people. So data will be keep on uh, taken into account for processing. Okay, now if the data has been given to you, what you will be doing? You will be doing only two kinds of application. I mean, two kind of values in that one. One is you will be storing the data. Otherwise, you will be processing the data. Only two things we can do it in this data. Okay, then suppose I'm getting any file in my mail, what I'll be doing immediately, that file I'll be saved in one of my place. Then later I will be opening the file and be analyzing what is this file, who has sent it, what data is inside. So I'll be whether to read this file or edit this file, or I have to do any updation, so that I will be working on that file. That is called as process. Simply taking the file and storing in one place is called, just for storing point of view, we are not doing anything. Suppose same file, if I'm doing any processing like editing or updating or reading or writing, whatever it is, we call this a process. So these two things has been followed in your data. Okay, now the data, that's what the data will be collected, and it will be availability for entire time. Whenever you are asking, wherever you are asking, everywhere in front of you the data will be available. Nowadays n number of data are available, so they are going for automated data collection tools and database systems and web computerized societies. Okay, major source of this abundant data is where this data is mainly available. Suppose in business, it is in web, e-commerce, transactions, stocks, etc. The people are very much involved in data. If we come for a science, where a remote sensing, bioinformatics, scientific simulation, a society, and everyone will be holding your news and digital cameras, YouTubes, etc. For example, if you want to buy any product, what we will be doing? First, we will be searching whether which type of product is very good, who is giving the best review, which company is good, what is the price, like that we will be finding the data, and then only we will be able to, I mean, we are interested to buy that particular product. That's what your society and everyone are relying on your data. Okay, we are drowning in data but starving for knowledge. What do you mean by that? Means n number of data are available in front of us, but we don't know from what the data is telling to us, or else what else we want from that data. We are not aware of that one. So for that scenarios only, we are going for data mining. It is helping us to dig the information from the data, and it is giving for you the knowledge to predict whatever you are interested and what you want. Okay, the next one is evolution of science. Okay, how this data can be come into picture. So previously there will be three type of eras. Actually, one is an RDBMS eras where you will be going for a unstructured data and structured data in the tabular format. Everything will be available. But why have the in that era? What is the limitation? Means it is size, because we cannot hold a more number of data. So depends upon the size, we have to save our data. And that particular RDBMS will be having only for a specific organizations. So we cannot transfer the data. So that was the first era of RDBMS. Second, it has come as a web data. So in that web data, internet has been emerged where it is a global sharing has been happened, and the sharing of a database is also allowed. So that was the web data. So that is also we having a size limitations, how much data to send, what to send, where to send, such restrictions was there. Then now it is in a smart era where we are getting a smart data. Now smart data is we are getting a data from your smart applications, your mobile phones and machine generated data. These are all comes in the smart data. So if you take it in a evolution point of view, before 1600 it was empirical science, and 1600 to 1950 it was a theoretical science. So here each discipline has grown a theoretical or component wise, where it's motivate experiments and generalize our understanding. The next one is 1950s to 1990s. It was a computational science. Okay, here over the last 50 years, most disciplines have grown a third generation. Okay, computation on branches. That is empirical, theoretical, and computational, ecology or physics, etc. Okay, computational science traditionally meant simulations. It grew out of our inability to find closed form solution for complex mathematical models. Okay, if you see here the statistics and interdiscipline with the data mining, because when in a real world scenarios we cannot work with the exact data what we because due to time constraints and the cost, we should go for a simulations. So where the simulation data plays a major role. If we come across 1990 and above that, there existed data science. That was the flood of data from new scientific instruments and simulations. So here from this one, what we are coming to know is this data science. There are two technologies we'll come across. One is a data analytics and data analysis. If you are this data analytics also called as data science. Okay, we'll see what is this one. First, data analysis. Here, suppose 1 GB of data about the customer. Suppose data analysis will give, for example, 1 GB of data about the customers for past 1 year. That is the data analysis. If you take the same data for data analytics, it will predict what will happen in future. That is our data science. I'll repeat once again. In data analysis, it will tell the customers past year experience, and data analytics or data science will be predicting the future analysis of the customers. So this is what the two difference between data analysis and data analytics. In data analysis, the mainly they will be depending on database, data warehouse and programming language. If we come for a data analytics, it is all these scenarios also will be work over here. Your database, data warehouse, programming language. Apart from that, you should be very good in maths, algorithms, programming language, etc. to work with your data science. Okay. Next one is evolution of a database technology. In 1916s, if you have data collection, database creation, information management system, and neural DBMS was available. In 1970s, you can see the relational data model and relational DBMS were implemented. In 1980s, you have come across the advanced concept of object-oriented concept. So all the things will be converted to your concepts. In 1990s, they come into picture of a data mining, data warehousing, multimedia database, and web database. In 2000, above we have come to stream data management and mining. Data mining and its applications and the web technologies where your XML and global information system has taken into account. Okay, now we'll see why is data mining. Now we have seen what is previously, so far we have seen what is data, what is information and what is knowledge and what is an evolution of a database, in which era now we are in. So all those things we have come across. Okay, now data mining. So data mining is nothing but knowledge discovery from data. That is an extraction of interesting patterns or knowledge from the huge amount of data. Okay, this is what we are going to go through in this unit. Okay, what are the other names for this data mining is, we are calling it as a knowledge discovery in database, knowledge extraction, data or pattern analysis, data archaeology, data dredging, information harvesting, business intelligence, etc. Okay. So if we come across, is everything is data mining, simple search and query processing, your expert system, that is a deductive expert system. So there is some difference between what is exactly data mining. Searching will not come under a data mining. So our interest, our patrons, whatever it is required, which is giving as a deep knowledge, we are calling it as a data mining. Okay. If you see the knowledge discovery, that is KDD process. Okay, if you see, this is the view for a typical database and data warehousing communities. Okay, already you might have seen in the first 1 or 2 units what is your data warehousing. Okay, this is the new thing where we will be studying for a data mining. So that data warehousing is nothing but the huge storage of the data. From that data, how the information has been mined only are going to study in this concept here. This is a view from typical database systems and data warehousing communities. If you see here, the down is your data cleaning. So here the database will be having a collection of your data. From this data, you will be cleaning the data. What do you mean by cleaning the data? Suppose some data might be having the missing values or incorrect values. The values which is not relevant will be given. So such type of data has to be eliminated. That is called as data cleaning. And the next one is data warehousing. So once the data has been cleaned, it will be placed in the data warehouse, which is a multidimensional storage, which is holding all type of data. So from this data, what is my task, what I want for my analysis, only those type of data will be taken. That is the task relevant data will be selected. So once it has been selected, it will be going for data mining. That means what type of knowledge I want. In this one, what I concluded, how to increase my profit or how to take my customers in the higher level. So like that, whichever area I'm interested, so like that I'll be mining the data in your data warehouse. And then after that, the main thing is it has to be known for all the people who is expecting the data. So that is a pattern evolution. So the data has to be predicted in the good format. All the user has to be understand the data. That is a pattern evolution. It should be neatly presented so that we can gain a knowledge from this one, which is all this thing is called as a cyclic product. So each and every time it has to be going in the refined model, and once it has been taken a scenario of one cycle, it has to be integrated. Like that, it has to be keep on increasing. That is, after the data cleaning, it will be going to data warehousing. From the data warehousing, all the process will be taken in the data mining to give your data. Okay, next one is a web mining framework. How this web is going to work for our data. First one is data cleaning. Second one is data integration from multiple sources. So data will not be taken from only one sources. We can take it from database or a files or a machine generated data or application generated data. So it has to be come from a multiple source. And warehousing the data. That first the data in whichever application it is coming, it has to be stored in a particular place, that is warehousing the data. Next one is a data cube construction. So based on the data in the different angle, it has to be constructed. That is the data cube constructions. In one way, I have to find in which area that the product is very good. So that one, or which age group that product has been selling more. Like that, in each and every aspect, I'm going to construct my data. That is a data cube construction. Next one is a data selection for a data mining. So once all the data, when all the angle it has been given. So what is my interest? Which type of data I should select? It is based on the criteria what I'm going to do. That is my data selection. So data mining is from that I'm going to get the information and knowledge. So presentation of mining results. Once I get the informations from that particular data warehouse and storage area, it has to be presented in a good format so that people will be able to understand. That's what we are coming for, the presentation of the mining results. And next one is a patterns and knowledge to be used or stored into knowledge base. Once we have get one conclusions in different angles, that has to be preserved for the later use. That is called as a knowledge base. So this is the steps which we are going to follow in the web mining framework. So next one is a data mining in a business intelligence. So here this